Today we're going to learn about cofunction identities. So here's a unit circle, and this is the point cosine sine, because remember cosine is x, sine is y, so that is the coordinate. Now, if I go backwards negative pi, I'm going to go back this way and form negative theta. I think I said negative pi by accident. I'm going back negative theta. My new coordinate is right here, and that's going to be cosine theta and a negative sine theta, because remember, this is x and now this is a negative y. So when I go backwards negative theta, sine became negative. However, cosine, when I went backwards, stayed positive. So let me apply an example here. Let's pretend theta is 60 degrees. At 60 degrees, cosine at 60 degrees is 1/2. Sine at 60 degrees is square root of 3 over 2. So when I plug in a negative 60 degrees, I'm now down here, and this is my new coordinate. Cosine at negative 60 degrees is still 1/2. However, sine at negative 60 degrees is now negative square root of 3 over 2. So basically, sine became negative while cosine remained positive whenever I plugged in a negative theta. Let's look at different identities. So for this one, this says sine of 180 degrees. So I'm going to go 180 degrees to where I'm right here. And then I'm going to go theta degrees more. So that means I'm going to add theta. I'm going to add theta more. So that means the coordinate here is negative cosine theta and negative sine theta. So that means this became negative sine theta. If it helps you to understand this by changing this to 60 degrees or something else, you went 180 plus 60 degrees more. So you went 180 and 60 degrees more, you're right here. So your coordinates changed. They're both negatives now. So that became a negative sign. For cosine in the same scenario, it also turned negative. And your tangent, since you have a negative over a negative, this is a positive tangent. Okay, now let's look at whenever we subtract theta. So I'm still going to go 180 degrees. You always start on the x-axis. And I'm going to go 180 degrees. So I'm here. However, this says to subtract theta. So I'm going to go back theta. So this is 180 degrees minus theta is what I did. So this is my new triangle. The coordinates here, cosine is negative, but sine is positive. So that means this is a positive sine, and this is a negative cosine whenever I subtract theta from 180 degrees. Tangent in this scenario will be negative. Now, guys, if you wanted to represent this in radians, just as a side note, you can also write this as cosine of pi plus theta. Or you can write this as sine of pi minus theta. You can replace these 180s with a pi and express it in radians. Right? This is expressed in degrees, 180 degrees. Okay, so now we're going to do 360 degrees, and we're going to add theta. So I'm right here, and I go a full circle to do 360 degrees, and I'm going to go theta more. So I did 360 degrees, and I'm adding theta. So I'm back in the same spot, So cosine and sine, that didn't change. So this is still sine theta. This is still cosine theta. And of course, tangent is sine theta over cosine theta. And it's positive. So this is tangent theta. Okay, now I'm going to go 360 degrees, but I'm going to subtract theta. So let's look and see what that would look like. So I'm going to go start on the x-axis, and I'm going to go around the circle 360 degrees. And then I'm going to subtract theta. So now I am here. I subtracted theta from 360 degrees. So this is my new triangle. I'm right here. So the coordinate here is cosine theta, but my sine is negative right here. So sine became a negative, and cosine remained the same. Tangent, you have a negative sine over a positive cosine. So when you have a negative over a positive, that's negative. So this is negative tangent. And this makes sense because, guys, when you think about the abbreviation all students take calculus. All means all the trig functions are positive. S, students, think about sine. Sine is positive in this quadrant, in the second quadrant. The only thing that's positive in the third quadrant is tangent. So think about this as tangent. All students take, and then calculus, think of cosine. They both start with a C. Only cosine is positive in the fourth quadrant. So if you look at these, the only thing that was positive in this quadrant right here was cosine. The other two were negatives in the fourth quadrant. Okay, all students take calculus. All the trigs are positive in the first quadrant. Only sine is positive in the second quadrant. Only tangent is positive in the third quadrant. And only cosine is positive in the fourth quadrant. Okay, so let's apply this. We are given cosine of theta is equal to 2/3. Well, if I draw my triangle, here's my theta. Cosine is adjacent over the hypotenuse. So that means the adjacent side is here, that's 2, and the hypotenuse is here, that's 3. If I want to find the missing side, I'm going to do Pythagorean theorem. 3 squared minus 2 squared will give me the missing side squared. So this is 9 minus 4, which is equal to 5, but I need to take the square root of that. So this is the square root of 5. That's the missing side. So that means sine of theta is opposite square root of 5 over the hypotenuse, 3. So if I did sine of, so pause here. I want you guys to answer A, B, and C. Pause the video and then come back and check. Sine of negative theta is equal to negative square root of 5 over 3. That's the identity. Remember, sine of negative theta is equal to negative sine. Well, sine is this. If I put negatives, that's what that would be. Negative square root of 5 over 3. Okay, next one. Let's think real quick. This is a triangle. Triangles equal 180 degrees. So this is 90. That means this angle right here has to be 90 degrees minus theta. Okay, if you don't get it, here's an example. Say this is 50 degrees. Well, to figure out this angle, you have to do 90 minus 50 to get 40. So this is 40 degrees. So this angle right here is always 90 degrees minus your theta, whatever this is, okay? Another way to say 90 degrees is pi over 2. So this is what this is saying. So basically, guys, I have a right triangle. Sorry, it doesn't look like one. this right here is pi over 2 minus theta. So the opposite side is 2. The hypotenuse is 3. So this is also 2/3. Okay. Okay, continuing. This one right here, it wants pi plus theta. Remember, this is theta. So we're now going to add pi to it. So if I add pi to it, I'm down here. So this is theta plus pi right there. Okay, so that means I went -2 this way, and your hypotenuse is still 3. So cosine of this angle is -2 over 3. Try to answer these on your own. Pause the video. I'm going to go ahead and go over it. Cosine at pi over 3, that's just 1/2. All you got to do is think about the unit circle. This is pi over 3, so the coordinate is 1/2 square root of 3 over 2. Since it wants cosine, you choose the x value. Sine of 13 pi over 6. Okay, so guys, they split pi into 6 parts. So this is 1, this is 2, this is 3, 4, 5, 6 pi over 6, which cancels out to be pi. This is pi over 6, 2 pi over 6, and of course you have to simplify these. Okay. Now, I already know this one. 13 pi over 6. So this is 7, 8, 9, 10, 11. This is 12 pi over 6, which is just 2 pi. And then this one is 13 pi over 6. So they're the same. It's the same angle. So this is also 1/2. Okay. I know that sine at pi over 6 is 1/2. Cosecant is just the reciprocal, so I have to flip this fraction. So it'll be 2 over 1, which is just 2. Did you get them right? Next one. Pause it, do it on your own. We're given sine of 63 degrees is x. So if I drew you a picture, this is 63 degrees. This is a right triangle. I know that 90 minus 63 is 27. So that means this angle is 27 degrees. Okay, so I drew my triangle based off of the information. Cosine of 27 degrees. Oh, let me finish my triangle. Sine of 62 degrees is x. I can put it over 1. That's opposite over the hypotenuse. Okay, so cosine of 27 degrees will be adjacent, which is the x, over the hypotenuse. 1. So this is just x. And if you remember the rule, cosine of negative theta is just cosine. So these are the same. These should equal one another. Okay, so now I have, this is my angle 63 degrees, and this angle right here is 243 degrees. All they did was add 180. Because 180 plus 63 is 243. So we're right here. So at this point, sine was equal to x. So right here, this will be negative x. Your hypotenuse is still 1. So opposite is negative x. Your hypotenuse is 1. So your answer is negative x. And if you remember the identity, sine of 180 degrees plus theta is negative sine. And that's what we got, a negative x instead of a positive x. Okay, pause it here and complete each statement. I'm going to go ahead and go over it. This is just the identity. It's negative a. So cosine is 0.4. That's the x value. If I go pi minus x, so here's pi right here. If I go back x, I'm right here. So that's negative 0.4 as your x value. Cosine of negative x. I'm sorry, sine of negative x. So we went down this way, negative x. So we're right here. In that coordinate, the y value is negative 0.13. Well, if I go positive x, the y value here will be positive 13. So it has x, and then they added a circle. So if I go all the way around the circle, come back, I'm still at 0.13. Okay, cosine of 47 degrees. I'll draw a picture. This is 47 degrees. I'll put it over 1. This is adjacent over hypotenuse. So this is adjacent over hypotenuse. So if this is 47 and this is a right triangle, 90 minus 47 is 43. So this is 43 degrees. So if I do sine of 43 degrees, that's opposite, which is y, over the hypotenuse, 1. So it's just y. I'm going to add one more problem to this. So, okay. This is the next question. Pause it and try to solve it. I'm going to go ahead and go over it. So they split pi into 5 sections. So this is pi. This is 1, 2, 3, 4. This is 5. 1, 2, 3, 4, 5 pi's over 5. 4 pi out of 5, 3 pi out of 5, 2 pi out of 5, and 1 pi out of 5. Okay, so they're saying that sine is y over 1. Okay, so I know this is y. So 4 pi over 5 right here. This is also y. So sine of pi over 5 is y, and so is sine of 4 pi over 5 y. Well, cosecant is just the reciprocal. So cosecant of 4 pi over 5 is, you just flip this fraction, it'll be 1 over y. So that's 1 over y. Okay, this is the last problem. Pause here and try it on your own. Tangent is y over x. So this is y over x. You're going to put 0.8 divided by 0.6. I believe you get 4/3 or 1.33. So that's the answer. Next one, we're going to go 180 degrees from the x-axis and then go back theta. So this is 180 degrees, and then we're going to go back theta. So 180 degrees, subtract theta. So now I'm right here. So the new point is negative 0.6, 0.8. So cosine is negative 0.6. Now we are going to go pi, and then we're going to add theta. So going pi, the distance pi, and then I'm going to add theta. So I'm going to go add theta. So I'm right here. This coordinate is negative 0.6, negative 0.8. So the sine value is negative 0.8. Next is tangent. We're going to go 360 degrees and then subtract theta from that. We're going to go back theta. So we start here and we go around the circle of 360 degrees, and then we're going to go back theta. So this is 360 degrees minus theta. That's what that angle is. So here's my new coordinate, and it is 0.6. Cosine is positive in the fourth quadrant, but my sine is negative. So tangent is going to be negative 4/3 or 1.33, negative 1.33. Okay, Cosecant is the same thing as 1 over sine, right? They're reciprocals of each other. So sine of negative theta is just negative 0.6. 1 divided by negative 0.6, I believe you get negative 1.25. There you go. That's the end of the lesson.